Acids! The very word can make you think of bubbling potions and science experiments. They are all around us in the foods we eat, like lemons and vinegar. They are even in our own stomachs, helping us digest our lunch, but not all acids are created equal, folks. Some acids are incredibly gentle, while others are so powerful they demand our utmost respect and caution. Today we're diving deep into the world of the strong acids. These aren't your everyday kitchen acids. We're talking about chemicals that can dissolve metals, etch glass, and cause serious harm if mishandled. Why learn about something so dangerous? Because science is all about understanding the world around us, including the hazardous parts. Knowledge helps us stay safe and appreciate the power of chemistry. Many strong acids are vital in industries that make things we use every single day. So while they have a dangerous reputation, they are also incredibly useful tools when in the right, well-trained hands. This journey is about pulling back the curtain on these powerful chemicals, not to scare, but to inform and to marvel at their sheer chemical might. Are you ready to learn about the world's most dangerous acids? Let's get started on this incredible chemical quest together. First up on our list of formidable fluids is hydrofluoric acid, often called HF. HF might not always have the lowest pH value, but its danger is incredibly sneaky and profound. Hydrofluoric acid has a unique ability to penetrate deep into tissues. It can even go through your skin and damage your bones without you immediately feeling intense pain on the surface. This delayed reaction makes it particularly treacherous. Next, let's talk about sulfuric acid, or H2SO4. It's used to make fertilizers, detergents, batteries, and so much more. Concentrated sulfuric acid is highly corrosive and a powerful dehydrating agent. This means it can pull water out of almost anything it touches, including your skin, causing severe chemical and thermal burns. And then we have the superacids. These are acids that are even stronger than 100% pure sulfuric acid. One of the most famous is fluoroantimonic acid. Its chemical formula is HSBF6. This substance is so incredibly strong it's hard to even comprehend. It can protonate almost any organic compound, tearing molecules apart with astonishing ease. These three, hydrofluoric acid, sulfuric acid, and fluoroantimonic acid, represent different facets of what makes an acid dangerous. So, what exactly makes an acid, well, an acid? It mostly comes down to protons, folks. An acid is a substance that can donate protons, or hydrogen ions, H+, to another substance. The more easily a substance gives up these protons, the stronger the acid generally is. The strength of an acid is often measured using the pH scale. The pH scale runs from 0 to 14. A pH of 7 is neutral, like pure water. Substances with a pH less than 7 are acidic, and those with a pH greater than 7 are basic or alkaline. The lower the pH number, the more acidic the substance. Corrosivity is another major factor making acids dangerous. Corrosive substances can destroy or irreversibly damage other materials they come into contact with, including living tissues. It's complex chemistry in action. Let's talk about what happens when these super strong acids meet everyday materials. Consider glass. Hydrofluoric acid, HF, reacts with silicon dioxide, the main component of glass, dissolving it. That's why HF cannot be stored in glass bottles. It needs special plastic containers. Now, what about metals? Many strong acids are famous for their ability to dissolve metals. When these acids come into contact with metals like iron, aluminum, or zinc, they react vigorously. This reaction often produces hydrogen gas, which is flammable, and a metal salt. The metal itself appears to be eaten away, sometimes quite rapidly. And then there's human tissue. Strong acids react destructively with organic compounds in our bodies. When a corrosive acid like concentrated sulfuric acid touches skin, it immediately begins to denature proteins and pulls water out of the cells. This causes severe chemical burns that can be incredibly painful and damaging. Hydrofluoric acid is uniquely dangerous to tissue because the fluoride ion penetrates deeply, causing not just surface burns but also damaging underlying bone. Sulfuric acid causes horrific burns due to its corrosive and dehydrating nature. Superacids like fluoroantimonic acid are so aggressive they would cause catastrophic and instantaneous destruction of tissue. They would decompose the organic molecules almost instantly. These substances demand our full attention and respect for their immense chemical power. Hydrofluoric acid, or HF, deserves its own special section because it's a bit of a chemical wolf in sheep's clothing. While it's classified as a weak acid in terms of how much it dissociates in water, its danger level is extraordinarily high. The real problem with HF lies with the fluoride ion it releases. This ion is small, highly reactive, and has a nasty affinity for calcium and magnesium ions in our bodies. When HF comes into contact with skin, it might not cause immediate searing pain. Sometimes, especially in lower concentrations, the pain can be delayed for hours. During this time, the HF is insidiously penetrating deep into the tissues. This delayed onset of symptoms makes accidental exposure particularly dangerous. The burns caused by hydrofluoric acid are often deep, excruciatingly painful once the pain does set in, and slow to heal. More systemically, if enough fluoride is absorbed, it can lead to serious health problems. Knowing these specific dangers is the first step to preventing a terrible accident. Sulfuric acid, or H2SO4, is one of the most widely produced industrial chemicals in the world. It's a key ingredient in making so many things we rely on. Think about fertilizers that help grow our food. Sulfuric acid is crucial in their production. It's used to make detergents, plastics, synthetic fibers, and even the electrolyte in lead-acid batteries. But this industrial giant has a very dangerous side, especially when it's concentrated. Concentrated sulfuric acid is typically about 98% H2SO4. At this concentration, it is highly corrosive. If it spills on your skin, it will cause severe chemical burns very quickly. But it doesn't just burn like other acids, it also has a powerful dehydrating effect. This means it aggressively removes water from whatever it touches. Because it's so widely used, accidents with sulfuric acid can and do happen. It's a powerful tool, but one that demands constant vigilance. Fluoroantimonic acid, the undisputed champion of acidity. Now, let's venture into the realm of superacids. These are acids that are, by definition, stronger than 100% pure sulfuric acid. And when we talk about superacids, one name often rises to the top: fluoroantimonic acid, or HSBF6. This substance is so incredibly potent that it makes even concentrated sulfuric acid look mild in comparison. We are talking about an acid that can be up to 10 quintillion times stronger than 100% sulfuric acid. Its acidity is measured on the Hammett acidity function scale, where it can reach values as low as -31.3. That's mind-bogglingly acidic. Fluoroantimonic acid is a mixture of hydrogen fluoride and antimony pentafluoride. Antimony pentafluoride is an extremely powerful Lewis acid, meaning it's very good at accepting electron pairs. When HF reacts with SBF5, the antimony pentafluoride grabs the fluoride ion from HF, leaving behind a very reactive proton. Because it's so powerful, fluoroantimonic acid reacts violently with most known substances. It truly is the king of acids, a chemical of almost unimaginable power. History, unfortunately, is peppered with incidents involving dangerous acids, serving as stark reminders of their potential for harm. These accidents range from individual laboratory mishaps to large-scale industrial disasters, each offering painful but valuable lessons. Laboratory workers have suffered severe burns and long-term health consequences from accidental splashes or spills of acids like hydrofluoric acid or sulfuric acid. One notable type of incident involves the transportation of acids. Sulfuric acid, being transported in vast quantities by road and rail, has been involved in spills due to tanker accidents. Hydrofluoric acid incidents are particularly harrowing due to its insidious nature. Every accident reinforces the message: dangerous acids demand respect, rigorous control, and a profound commitment to safety and responsible use. Knowing about dangerous acids is one thing, but knowing how to handle them safely is absolutely crucial. The number one rule when working with any hazardous chemical, especially strong acids, is personal protective equipment, or PPE. Always wear chemical splash goggles to protect your eyes. A face shield over the goggles provides even better protection for your entire face. Wear appropriate chemical-resistant gloves. The type of glove material matters. For example, standard latex or nitrile gloves might not offer sufficient protection against highly corrosive or penetrating acids. An acid-resistant apron or a full chemical-resistant suit might also be necessary. Always work with strong acids in a well-ventilated area, preferably inside a chemical fume hood. Proper ventilation is key to preventing respiratory exposure. Know your emergency procedures like the back of your hand. Locate the nearest safety shower and eye wash station. If acid gets on your skin or in your eyes, immediate and copious flushing with water for at least 15 to 20 minutes is critical. Safety isn't just a set of rules, it's a mindset. Be prepared, be cautious, and always prioritize safety.